Hello, everyone. Welcome back to Cyber in Practice, episode 13. Today, I'll be demonstrating data masking, a security technique used to protect sensitive information while still allowing organizations to use data for business operations. We briefly covered a concept behind data masking and then moved directly into a live demonstration using Python and Kali Linux. What is data masking? Data masking is the process of hiding portions of sensitive information while preserving enough data for legitimate business use. Instead of exposing full records, only information necessary for specific tasks is displayed. This helps protect privacy, reduce risk, and support secure data handling. To understand why organizations invest in masking technologies, let's look at the risks associated with exposing sensitive information. Why data masking matters. Without data masking, sensitive information can be exposed through reports, applications, logs, and other systems. This increases the risk of unauthorized disclosure, insider threats, privacy violations, and accidental data leakage. Data masking helps reduces the risk by limiting unnecessary visibility. Now we look at some of the security controls organizations use to accomplish that. Organizations typically use either static masking or dynamic masking. Static masking permanently protects data in non-productive environments, while dynamic masking hides information in real time based on users' permissions. Both approaches help reduce exposure while maintaining usability. These controls allow organizations to balance the security requirements with business operations. In this demonstration, we'll focus on masking common types of sensitive information, including email addresses, credit card numbers, and account identifiers. The objective is to protect confidential data while still allowing authorized users to identify records and perform their work. Let's now look at what we'll accomplish in this demonstration. Our demonstration has 5 objectives. Review the original data, apply masking through Python automation, generate protected output, compare results, and evaluate the security benefits. Rather than simply discussing data masking, we're going to watch it happen step by step. For this exercise, I'm using Kali Linux virtual machine with Python and a sample customer data set. I chose Python because it allows organizations to automate masking rules consistently across large databases, reducing manual effort and human error. Let's move on to the demonstration and see the concepts in action. First, I'm navigating to the project directory that contains our customer data and masking solution. Here we can see the original customer information. Notice that the email address, credit card number, and account number are fully visible. In a real environment, exposing this information unnecessarily creates security and privacy risks. This is exactly the type of data an organization works to protect. I'm going to use Python script that automatically identifies sensitive fields and applies masking rules. Rather than manually editing records, automation ensures consistency and scalability across large amounts of data. This helps organizations protect information efficiently while reducing the possibility of human error. This executes masking process and generates a protected output file. The script applies predefined masking rules to sensitive fields while preserving the overall structure of the data. Now we can see the protected version. The email address is partially hidden, the credit card display only the final 4 digits, and the account number is masked as well. Notice that the information remains recognizable enough for business use, but the most sensitive portions are no longer exposed. This significantly reduces the risk associated with unauthorized access. Comparing the original and masked version clearly show how sensitive information has been protected without removing the business value of the data. Users can still identify records and perform their work, but they no longer have unnecessary access to the complete sensitive values. What we've seen is a practical example of how organizations reduce data exposure. Rather than completely removing data, masking limits what a user can see based on business needs. This helps support privacy requirements, reduces the impact of accidental disclosure, and strengthen overall data protection. Now that we've completed the demonstration, let's review the workflow one final time. We started with sensitive information, applied automated masking rules, generated protected output, and then validated the results. Throughout the process, the goal remained the same: reduce exposure while preserving usability. This workflow demonstrates how organizations can protect sensitive information without disrupting normal business operations. With that in mind, let's wrap up the key takeaways. To conclude, data masking helps organizations protect sensitive information, supports privacy requirements, reduces the risk of unauthorized disclosure, and maintains business usability. As demonstrated today, a simple automated process can significantly improve data protection while preserving operational functionality. The key takeaway is that not every user needs access to every piece of information. By limiting visibility to only what is necessary, organizations can reduce risk while continuing to support business operations effectively.
Thank you for watching Cyber in Practice. If you enjoyed this demonstration, stay tuned for future Cyber in Practice episodes.